Hey everyone, and welcome to the first episode of my podcast, Blown Up Concepts. In this podcast, I intend to explain a variety of complex words in the tech world in a seemingly simple way, so anyone can understand them even if they are not a technical person. Are you ready? Let's go! Hello again everyone, Yuval is here, and today I'm going to talk to you about CNC. Now, what exactly is a CNC? It's a short for Computer Numerical Control. And as the name implies, CNC is a method of automatically controlling a machine using a computer. A CNC machine creates a physical object out of graphic file on your computer. The variety of CNC machines in the world is huge. We are talking about a milling machine, a lathe, a laser cutter, plasma cutter, pick and place machine, 3D printers of course, and a wide range of motorized machines that contain between 2 to 6 axes, as far as I know. Now, by definition, a CNC machine is a machine that performs a machining process on a piece of material. Now, I do not completely agree with this definition, but we'll talk about it in a moment. This means that a CNC machine gets a chunk of existing material, such as metal, plastic, wood, ceramics, glass, you name it, whatever you want, and performs predetermined operations automatically. So there's no manual intervention at all. The commands sent to a CNC machine from the computer are called G-code. There's also M-code, but let's not complicate the things right now. When you want to produce a part, you first design it, or rather model it, with a graphic software called CAD. CAD is a short for Computer-Aided Design. Then you need to send the model you created on the software to a different one called CAM, which stands for Computer-Aided Manufacturing, which creates the G-code for the machine, of course. And as we said, G-code is the operation instructions. Now, I use a software called Fusion 360 by Autodesk that contains CAD and CAM together in the same software, which is super cool. And it's free to use for hobbyists, so I highly recommend it. It is very simple and intuitive to operate, and it has a built-in simulator and many other interesting features. And there's also a huge community on the internet, so anyone can use them. It's super cool, go for it. Now, let's talk about 3D printers. With them, it's a bit different because instead of using a CAM software, you use a slicer that actually slices the object you modeled into very thin slices, and it also refers to parameters you entered, such as layer thickness, fill percentage, and many more parameters, and eventually export a G-code to your machine. For the printer, of course. Now, the last step is to upload the G-code to the software of your machine, which controls the printer or the CNC or whatever it is, and it will function as an interface between the computer and your CNC machine. And of course, it will ensure that the machine performs the same operations that are set for it. Now, earlier I said that I tend to disagree with the definition of a CNC machine, so let me explain to you why. A CNC machine is a motorized control tool that is being controlled by a computer according to specific instructions, like I said before. But unlike a CNC machine, which removes material from stock, what's so-called subtractive process, there are 3D printers that do the exact opposite. They are called additive process. They do not receive a chunk of material, rather creating one from scratch in different methods like FDM, where you melt a filament. There's also SLA, where you dry resin with UV light. And there are many more, but a very cool one is printing metal from powder using a laser. It sounds crazy. Like, I think I saw a couple of machines a few days ago or a few weeks ago at the WeWork in Tel Aviv, There's a company there called Metal Point or something like that. I actually got there accidentally, but I was fascinated by their place and their crazy tools and printers. And the operation guy that was there at the moment was super nice, and he gave me a short tour with explanations and showed me a few examples that they printed. These machines are super cool and can print parts from stainless steel, titanium, and many other metals in a very high level of accuracy. Now, the only disadvantage is that it takes a lot of time to print one. Let's take, for example, an object in the size of let's say your hand. I think it will take like about a day or so, even more than 24 hours. Anyway, let's get back to my point. So, in my opinion, any motorized machine that is automatically controlled by a computer using a G-code is called a CNC. No matter if it does an additive process or a subtractive process. Now, how CNC machines work? Basic CNC controllers support machines with 3 axes: X, Y, and Z. X for left and right movement, Y for forward and backward, and Z for up and down. Most sophisticated machines allow rotation of the machined part or tilting the milling head itself at an angle around the additional axis. They are called A, B, and sometimes even C, for example, when it comes to robotic arms. The position of the head is done by servo motors or stepper motors because it is necessary to reach high level of accuracy. And there are many kinds of motors like DC, gear, brushless, servo steppers, and many others on the market, but not all of them are as accurate as servo motors and steppers. So when you use a CNC machine, you want the object you create to be exactly as the model you made on the CAD software. That's why we're using either servo motors or stepper motors. Okay, so let's take a moment of respect. So we defined what a CNC machine is and explained how its basic version works. But let's think for a moment about what was said and how cool these machines are. Factories that today use CNC machines can perform unattended repeated manufacturing operations for entire days while constantly checking the quality of the part by themselves. Like, it's automatically using sensors. You don't need any operation guy to come and check them and make the quality control because the machine is doing it by itself. It's amazing. Now, newer machines are even able to detect the fault and call an operator by sending a message, such as SMS or email, and sometimes to continue work and perform operations that do not concern the faulty part of them. For example, a milling machine that has broken one of the mills can replace to a different one and skip to another task until someone will come to replace the broken mill, and then the machine will be able to return back and to the operation it skipped. Like, it's amazing. It's mind-blowing. One interesting and fun fact to conclude: the first CNC machines were developed in the 40s or 50s, and they relied on data storage technology called punch tape. The code that controls the machine, like today's G-code, was punched into data cards, a physical data card, and was put into a system inside the machine that interpreted the card. Like, you had to do it manually. You had to take a card and punch it and then put it inside the machine, inside the CNC machine. Think how amazing machines today that you just model it, send it to the software, and it does everything automatically. Crazy, right? So that's all for today's class, guys. Thanks again for listening, and I really hope you now understand what a CNC machine is, how cool it is, and that you have to get one. I truly had the pleasure of passing to you some of my knowledge on CNC machines, and I plan for you a lot more interesting content for the near future, with interesting people, so stay tuned. Lastly, if you have any questions or concept that you would like to get more information about, or just an explanation in a simple way, You are more than welcome to send me a message on Instagram, kdtech.co.il, or search me through our website, www.kdtech.co.il. Stay creative, stay hungry for knowledge, and I'll see you next time.